Start, sir.
Okay, sir. Okay, welcome to this session. In this session, we have to explain about the P block elements. Actually, in P block elements, there is available 15th, 16, 17, and 18 groups. That means what? By clubbing 4 groups, we have to discuss about the P block elements in second year chemistry. Apart from this, we have to explain about the 15th group elements. Okay, then here in 15 group elements, there is available dinitrogen, ammonia, oxides, oxyoxides, then oxyoxides, then sorry for inconvenience.
Sir, share the screen, sir.
Okay, madam. Okay, so in this chapter, we have discussed about the 15 group elements: dinitrogen, ammonia. Second one, that is oxides, oxyoxides of nitrogen, phosphorus, as well as phosphines, along with the phosphorus halides and oxy acids of phosphorus. So this is about the content about the 15th group elements, right? So then, yeah, we are entering into nitrogen family. Nitrogen family also called as 15th group elements, as well as it is also called as 50th group elements. From this chapter, you have to get the 4 marks or sometimes 8 marks also. That's why you have to more concentrate the nitrogen family. Okay. Let's we discuss about the elements of 50th group elements. Right here in this group, there is available the elements are nitrogen, then phosphorus, then arsenic, then antimony, and the last one, that is bismuth. Okay, so here clearly I mentioned here clearly, yeah, this is about the 15th group elements. Right, the first one is nitrogen, which is containing atomic number is 7, as well as phosphorus, which is containing atomic number is 15. Then arsenic, which is containing atomic number is 33. Then strontium, okay, which is containing atomic number is 51. Last one, that is bismuth. Bismuth atomic number is 83. Okay, so then here, why the 15 group elements all called as P block elements? Because of there is some reasons. Those reasons we have to discuss now. What are those reasons? The difference of electrons are enter into p orbitals. Hence, it is present under P block elements. What is the meaning of differentiation? That means what? The entering of electrons. That means what? The entering of electrons are enter into P blocks or p orbital. Therefore, the nitrogen family is present under P block elements. Okay. Then second one here, according to above concept, we have to conclude the common outermost electronic configuration, that is valency orbital is ns2 np3. Just I told you the 15 group elements also called as 50th group elements. Why? Because it is called as 50th group elements. The in common outermost electronic configuration there is available 2 plus 3. 2 plus 3 means what? 5. That's why here the 15 group elements also called as 50th group elements, because of the s orbital is containing 2 electron and p orbital is containing 3 electron. By clubbing 2 plus 3, here it is 5. That's why it is the 15th group elements also called as 50th group elements. This is about the common. It is very the valency orbitals are containing 5 electrons. Hence, this group is called as fifth group elements. I told you just now. Okay. The general oxidation states. Okay, there is available. It will show the -3 oxidation state, +3 oxidation state, as well as that is +5 oxidation states also. That means what? All 15 group elements, that is 50 group elements, are show the -3 as well as +3 and +5 oxidation states. Right, then nitrogen is a diatomic molecule. You know already generally we have to recognize the nitrogen as the N2. N2 means what? Here the nitrogen is acting as a diatomic molecule because of here diatomic molecule because of smaller size and high electronegativity, and to forms p-pi multiple bonds. That means what? In between two nitrogen atom there is available triple bonds because of only reason is smaller size as well as high electronegative. Okay, so due to presence of these properties, there is available triple bonds in between the two nitrogen atom. Due to presence of the triple bond, the nitrogen atom is always written as the diatomic molecule. It is a very, very important reason during the nitrogen. That's why you have to remember this one. Okay, right? Then phosphorus. Here, phosphorus is containing single bonds, whereas in the nitrogen there is available triple bonds. Whereas in phosphorus there is available single bonds. Okay, that's why you have to more concentrate here. The phosphorus is containing single bonds between phosphorus atoms because of larger size and lower electronegative. Hence, the phosphorus will show the tetrahedral shape. That means what? Always phosphorus is representing as the P4. Always phosphorus is representing as the P4. Why? Because only the phosphorus will show the larger size. Okay, phosphorus will show the larger size as well as lower electronegative. When compared with, once again repeat, when compared with nitrogen, it is important point. When compared with the nitrogen, phosphorus will show the single bond. Okay, because of only lower electronegative as well as larger size when compared with the nitrogen. These 2 points are important points. That's why you have to remember it. Right? Then here once again, this group is also called as picogen family. What is the meaning of picogen family? Nothing but about here the nitrogen as well as the phosphorus atoms are the phosphorus atoms show the some strangerous smell, some strangerous, I mean it will create the, what are those? The nitrogen as well as phosphorus are create the some strangerous smells, strangerous feelings, emotions. Therefore, this group is also called as picogen family. Picogen family. And also in this group, the first element is nitrogen. The first element is nitrogen. Therefore, this family also called as nitrogen family. Okay. Group 15 elements include phosphorus, arsenic, antimony, and bismuth. Here, okay, the nitrogen is real constituent of the world air and records for 78% of it by volume. It is the primary member of this group and happens in free state as a diatomic gas, that is representing as the N2. That means what? Always nitrogen is present 78% in our atmosphere, in our surrounding air. Okay, surrounding air, right? Then it is also abundance in the air, right? Then nitrogen is present in saltpeter. Nitrogen is present in saltpeter. It is found in the form of proteins, plants, and animals. That means what? The proteins also containing nitrogen derivatives, plants also containing nitrogen derivatives, and animals also containing nitrogen derivatives. That means what? There is play the important role the nitrogen. right? Then phosphorus occurs in minerals family. That means what? Phosphorus also more abundance as in the minerals, right? Then phosphorus is essential constituent of animal and plant matter. Phosphorus also plays the important role, various like in animals as well as plant matters. Phosphorus is okay here. Phosphorus is present in milk and eggs. That means what? Here phosphorus also plays important role to improve the to animals or human beings what are maybe life organs. Right here, arsenic, antimony, and bismuth are found mainly as a sulfide minerals. That means what? Arsenic, antimony, bismuth. Those three elements are found in the form of the sulfide minerals. Sulfide minerals, right? So this is about the occurrence of 15 or 50 group elements. Okay, next. Here we have to write here some electronic configurations. Yeah, what is the meaning of electronic configuration? The systematic arrangement of electrons. The systematic arrangement of electrons in the suitable orbitals are called electronic configuration. Simply, configuration means what? Systematic or regular pattern. Arrangement of regular pattern of electrons are called electronic configuration. Here we have to use here always noble gas. So by using noble gases, we have to write the simple electronic configuration. Okay, here the nitrogen atomic number is 7, yeah, which is containing 2s2, 2p3 common outermost electronic configuration. That is, these all are called valency orbital of the nitrogen. Whereas here phosphorus atomic number is 15, the electronic configuration is neon 3s2, 3p3. Here arsenic, the atomic number is 33. Yeah, the electronic configuration is argon 3d10 4s2 4p3. Here strontium, yeah, the atomic number of strontium is 55. The electronic configuration is chromium 4d10 5s2 5p3. Last one, that is bismuth. The atomic number of bismuth is 83. The electronic configuration is xenon 4f14 5d10 6s2 6p3. By using this all electronic configuration, we have to conclude the common outermost electron configuration is what? Always s2 p3 s2 p3 s2 p3 s2 p3. That means what? We have to conclude the common outermost electronic configuration of 15 group elements is ns2 np3. N is number like 2 3 4 like that. That's why we have to conclude ns2 np3 is a common outermost electronic configurations or are valency orbitals, right? So this is about the electronic configurations. Then the atomic and physical properties of 15 group elements. Okay, by using this table, we have to conclude these all properties. Like here, atomic symbol is nitrogen, then arsenic, antimony, bismuth. Yeah, atomic number you know already. Atomic mass is then 30.97. The atomic mass of arsenic is 74.92. The atomic mass of antimony is 121.76. And bismuth, the atomic mass is 209.98. Similarly, yeah, just I we discussed already about the electronic configuration. So leave it. Then melting point and boiling points. Okay, here in you have to know about the groups and the periods. What is the meaning of groups and period? Yeah, according to our periodical table, there is available 18 groups. There is available 18 groups and 7 periods. That means what? Always in groups are nothing but what? Where we have to forward, that is, we have to read as the top to bottom. Top to bottom in the periodical table is called groups, and left to right in the periodical table is called periods. Okay, top to bottom is a groups, left to right is a period. Okay, so that's why we have to read about here groups property. Here we have to read about only groups property. Okay, this table also belonging to group property. Right here, in this case, already you know about the electronic configuration, whereas here melting and boiling points. Okay, here melting and boiling points are present in the irregular pattern. That means what? Here the melting and boiling points of the nitrogen is minus 210, and next one melting point of the phosphorus is what is that? 44.15, whereas here arsenic is containing 817. What is the reason? Whereas here antimony, again here is more value, here it is less value, here it is again less value. That means what? The melting point and boiling points of nitrogen increases and nitrogen to phosphorus. Here the arsenic is containing more melting and boiling points because of the arsenic is participate in the sublimants. I mean what? Sublimation. What is the meaning of sublimation? The conversion of solids into gases without form of the liquid is called sublimation. Due to presence of the sublimation property of arsenic, it will show the more melting and boiling points. Okay, this is a reason. So that's why here the melting and boiling points are present in the irregular pattern in the groups. Okay, so right then density. Density always increases in the groups. Increases in the groups. Okay, then what about the atomic radius? Here atomic radius is mentioned in PM. That means what? Picometers. Already you know atomic radius also increases down the groups. Increases down the groups. Clearly I have to mention here the nitrogen atomic radius is 56, phosphorus atomic radius is 98, arsenic atomic radius is 114, antimony atomic radius is 133, bismuth atomic radius is 143. What you understood this one? By always in groups atomic radius is increases down the groups, increases down the groups because of by increasing atomic number to increase the atomic size also. By increasing size, ultimately the atomic radius also increases. Okay, so this is about the some physical properties of the what? Nitrogen family. Next, here, what is the meaning of atomic and ionic radii? Yeah, here the atomic radii, nothing but what? Actually, atomic radii also called as atomic radius. Radius is a singular word, radii is a plural word of the atomic radius. Okay, here you know all just I told about the always by increasing atomic number to increase the atomic size and also gradually increases the atomic radii in the groups from top to bottom. That means what? Ionic radii or atomic radii gradually increases down the groups. Gradually increases down the groups. Only reason is by increasing atomic size. Okay. Yeah, I told here atomic and ionic radii is increases down the groups because of increasing atomic number size. Okay, so this is about the atomic and ionic radii. Then what about the ionization enthalpy, which is represented by IE symbol? E means what? Enthalpy or energy, whatever maybe. That's why sometimes ionization enthalpy also called as ionization energy. Ionization energy. What is the definition of the here ionization enthalpy or energy? Simple. The definition is amount of energy is required to eliminate the electrons from isolated gases system is called as what? Ionization enthalpy. Once again repeat you, the amount of energy is required to eliminate the one electron from isolated gases system is called ionization enthalpy or ionization energy, which is represented by IE symbol, which is represented by what? IE symbol. Here, ionization enthalpy values are decreases down the groups because of increasing atomic size down the groups. That means what? Always I told you, always groups from top to bottom, atomic size is increases. By increasing atomic size, there is decreases the ionization enthalpy in the group. Okay, in the group, right? Then electronegativity, which is represented by En symbol. What is the meaning of electronegativity? Yeah, you know already the electronegativity, nothing but it is a one type of ability. One type of ability which can attract the shared electrons, which can attract the shared electron. That is called as what? Electronegativity. Electronegativity, which is represented by, already I told you, En, right? Here, it is decreases down the groups because of increasing atomic size down the group. That means what? Here, ionization enthalpy is decreases as well as electronegativity also decreases down the group. Okay, so I will provide here one note that is very simple. Always atomic and ionic radii, which is represented by IR, values are increases down the groups. Similarly, ionization enthalpy or electronegativity values are decreases down the groups. That means what? Atomic radius as well as ionic radius is increases down the group, whereas here ionization enthalpy and electronegativity values are decreases down the group. It is a simple note, simple tip to remember about this one, right? This is about the enthalpy as electronegativity. Next, here once again some properties, that is especially for physical properties of fifth year group elements. Here non-metals. What are those non-metal? Here nitrogen as well as phosphorus, both are acting as the non-metallic properties, as well as metalloids. What is the meaning of metalloids? Metalloids also called as semi-metals. Semi-metal. Okay, what are those? Here there is available semi-metals like arsenic, antimony. Okay, arsenic, antimony. These two, okay, these two atoms are acting as a semi-metal, that is metalloid property. Then here only bismuth will show the metal property. Only bismuth will show the metal property. That's why. Because bismuth will show the metal property here in groups from top to bottom. From top to bottom, always metallic properties are increases. That means what? Yeah, here bismuth is a last element of fifth year group elements. That's why bismuth will show the more metallic in the nature. In generally, all groups are containing the last elements are show the metallic nature. In generally, all group elements are containing the there is available the first elements are show the non-metallic property. In between the starting elements and ending element, the middle elements are acting as the what? Metalloid property or are semi-metalloid properties. Okay, so then here most common forms. Here the nitrogen is more abundant as a, yeah, it is present in the atmospheric pressure. I mean, sorry, not pressure. The nitrogen is present in atmosphere. Okay. Similarly, phosphorus is more abundant in phosphate rock. Then arsenic, antimony, bismuth. These all are more abundant, like as in minerals like sulfide or oxides. Then antimony, bismuth. Okay, these all are present in the form of elements. Right. Right here. Here the nitrogen and phosphorus, these two elements are more abundant in the nature. What about the arsenic and antimony and bismuth? These three elements are less abundant in the nature. That's why these all are abundant, like very rare in our nature. Okay, from okay here these all elements are show the different oxygen states. I told you at the beginning of the topic. Once again repeat you during this slide. There is available. It will show the -3, +3 and +5 oxidation states. And as well as next point, the atoms have 5 electron in outermost energy level. Okay, you know already NS2 NP3. That's why outermost electronic configuration there is available 5 electrons. Then next point, exist in greater than or is equal to 2 allotropic forms. Actually, these group elements are show the 2 allotropic forms except nitrogen and bismuth. This is important one. This question is asked for your competitive level. Okay, then solids at room temperature except nitrogen. That means what? At room temperature, these all elements are show the what? Which state? Solid state except nitrogen. Nitrogen is present in the gaseous state. Okay. So this is about the some physical property that is important physical properties. Right. Then I told you what is the meaning of boiling and melting points. Before that, the meaning of boiling point means what? The conversion of the conversion of liquid into gaseous state is called what? Boiling point. Similarly, the conversion of solid into liquid is called melting points. Generally, here boiling points which is represented by BP or increases down the group. Melting points also increases up to arsenic. I told you just now. Melting points also increases up to arsenic, then decreases up to bismuth. What is the reason here? Here the arsenic is involving in the sublimation property. Sublimation property already we discussed. Okay, and then here chemical properties. We discussed already physical properties. Similarly, we are enter into chemical properties. Okay, here where the nitrogen is, here reactivity of hydrogen. Reactivity of hydrogen. Group 15 elements forms hydrides of the EH3 type. EH3 type. Where? What happened here? Where E is equal to group 15 elements. On moving down the group, the stability of hydrides is decreases. For example, the hydrides properties decreases in the groups. Here, always when the fifth group elements are react with hydrogen, then to form the EH3 type compounds, EH3 type product. For example, here nitrogen is react with hydrogen to form NH3, that is ammonia. That means what? This is a best example for what? EH3 type. Always E is equal to what? E is equal to 50th group elements, like NH3, PH3, ASH3, like that. So this is about the reactivity with reactivity with the hydrogen. Then second point is reactivity with the oxygen. Here when 50th group elements or 15th group elements are react with oxygen, then to form E2O3 type as well as E2O5 type. That means what? E2O3 means what? There is form trihydroxide, and here E2O5 means what? There is form pentoxide type products. Okay, so this is about the reactive with the oxygen. For example, how to provide example for E2O3 type? N2O3. N2O3 nothing but what? Dinitrogen trioxide. Here E2O5 type. That means what? Here example is N2O5. What happened here? Dinitrogen pentoxide. So this is about the reactivity with the oxygen. Okay. Similarly, third one is reactivity with the halogen. When all 50th group elements are reactive with the halogen, then to form EX3 type product. EX3 type product. What are those? Give me example for EX3 type. Here simple NCl3. NF3. That means what? NF3, trifluoronitrogen. And that means what? Here always EX3 nothing but what? Trihalides. Here EX5 is nothing but what? Pentahalides. Pentahalides. But here the nitrogen is less form in the EX5 type. Because of here nitrogen, there is not available the d orbitals. There is not available the d orbital, and also some more properties like due to presence of the more electronegative and less atomic number, the nitrogen should not form as a EX5 type. but more form as the EX3 type. Okay, this is the important point during the fifth year group elements are reactive with the halogen. Okay, right, then here it is very important one. Inert pair effect. What is the meaning of inert pair effect? Already we studied in first year chemistry. Here also again it is repeated. In this case, the definition is the reluctance of NS2 electrons in the bond formation is called inert pair effect, which is represented by IPE symbol. What it means what? Should not participate the NS2 electrons in the bond formation is called inert pair effect. Here one reason, here due to above effect, the bismuth is containing +3 oxidation state instead of +5 oxidation state. I told you here, the reluctance of NS2 electrons are, okay, that means what? Actually there is available NS2 NP3 common outermost electron. But here NS2 electrons should not participate in the bond formation. That's why here in bismuth it will show the +3 oxidation state instead of the +5 oxidation. It is important one. It is also asked for 2 mark purpose. Okay. So this is about the IPG. Then anomalous properties of nitrogen. Yeah, anomalous property is nothing but some special properties. Some special properties are abnormal properties. Always the first element of every group, will show the anomalous property. What is the reason why the first group elements are show the anomalous property? There is some properties are there. What are those properties? I have to highlight here. Right here, nitrogen differs from the rest of the members of this group due to the smaller size, high electronegativity, high ionization enthalpy, and non-availability of d orbitals. That means what? The nitrogen is nothing but it is containing very smaller size and high electronegativity. The nitrogen is containing 3.0 electronegativity value. Nitrogen is containing 3.0 electronegativity value. That's why the nitrogen show the more electronegativity in the group, within the group. That means what? It is the nitrogen compared with the following elements like phosphorus, arsenic, antimony. That's why in this group, nitrogen will show the more electronegativity, that is 3.0 value. And also nitrogen will show the high ionization enthalpy. And there is not present about the d orbitals. There is no d orbital present under nitrogen electronic configuration. So this is about this point. Then nitrogen has unique ability to form pi multiple bonds. Okay, pi multiple bonds with itself, and with other elements have small size and high electronegativity. That means what? The nitrogen is containing, it is ability to form the pi bonds in between two nitrogen atoms. We discuss next slide about this one. Right. Then on the contrary, phosphorus, arsenic, and antimony form single bonds. That is P single bond P. That is phosphorus bond phosphorus, arsenic bond arsenic, and strontium bond strontium, while bismuth forms metallic bonds in elementary state. However, the single nitrogen and nitrogen bond, that means what? Here the phosphorus as well as arsenic and strontium, in between these atoms there is available single bonds. That means what? In this state the phosphorus as well as arsenic and strontium, both these three elements are show the more stability. Whereas in nitrogen, if there is present single bonds, if there is present single bonds in nitrogen, the nitrogen will show the instability, because of there is available in nitrogen there is available one lone pair of electron as well as bond pair of electron. That's why there is more repulsions occurs. There occur more repulsions in between bonding electrons and non-bonding electrons in the nitrogen. That's why there is not form any single bond in the nitrogen. That's why there is available triple bonds in between any two nitrogen atoms. That means what? It is indicating as the nitrogen is more stable in the form of the presence of the triple bonds, whereas phosphorus, arsenic, antimony, these three elements are more stable in the form of the single bonds. Why? Because here the nitrogen, due to presence of the triple bond, the nitrogen will use the more bond dissociation energy. It will use the more bond dissociation energy. To using of more bond dissociation energy, it is indicating as the nitrogen will show the more stability, as well as it is involving in the less reactive in the nature, less reactive in the nature. So this is about the important point during the nitrogen. That's why you have to remember it. Okay, next. Here, dinitrogen. Here, yeah, you know already. Yeah, this is about we discussed now. In between two nitrogen atom, there is available multiple bonds like triple bonds. Okay, one is sigma bond, remaining two is pi bonds. Right. This is about the structure of the nitrogen. Here, nitrogen molecules are highly stable because strong triple covalent bond. Just I discussed already here. Okay, then in between two nitrogen atoms, yeah, we know already, the nitrogen show less catenation property. It is also important one. Why? Because here the nitrogen molecule will show the less catenation property. Why? Because there is the bond strength is very less, very weaker. The bond strength is very weaker. Therefore, nitrogen will show the less catenation property when compared with the remaining. In generally, the elements which are show the more bond strength, those all participate in the catenation. Due to presence of the less bond strength towards nitrogen, it will not show the what? Catenation property. Okay, then preparation and properties of dinitrogen. Yeah, here NH4 taken twice to Cr2O7 itself, it is heated. We have to get nitrogen as well as water and then Cr2O3. That means what? By using NH4 to Cr2O7, we have to prepare the nitrogen. Here we have to prepare the nitrogen. Right, then here BaN3 taken twice, 2 gives to form Ba plus, as well as here also in this reaction we have to get the dinitrogen. Okay, then here same NH4 taken twice, Cr2O7. It is also we have to use here heat then to form N2, that is dinitrogen as a gaseous state, and to form water molecule as well as Cr2O3. So along these three equations, we have to prepare the dinitrogen here, and also dinitrogen here. Thus, by using this all chemical reaction, easily we have to prepare the dinitrogen. Right here, properties about the dinitrogen. Here, what are those properties? It is a colorless. As well as odorless, tasteless, and non-toxic in the gas. Okay, it is a colorless, odorless, tasteless, and also it is not a toxic in the gas. It is chemically unreactive at ordinary temperature due to presence of triple bond. That means what? Actually, it is a chemically unreactive at room temperature, and also there is available to break out the triple bonds. To break out the triple bonds, we have to use the more dissociation energy. Already I told you. Okay. Now here some reactions. When dinitrogen, here dinitrogen is reacted with lithium, okay, to form what? Li3N. It is very, very important one. Similarly, dinitrogen is reacted with the magnesium metal to form what? Mgn2. That okay. So this is about the some chemical reaction during the nitrogen. Right, then Here, preparation of ammonia. It is very, very important one. Okay, in this chapter, Haber process is important one. That is preparation of ammonia is very, very important one. Here, how to prepare the ammonia? Here, when ammonium chloride is reacted with calcium hydroxide to form what here? Calcium chloride as well as water molecule and to form ammonia. So this is about the first preparation process of the ammonia, right? Here, the gas may be also made by the warming concentrated ammonium hydroxide. Okay, in this case here, always to prepare the ammonia, best example is by using ammonium chloride with calcium hydroxide to get the ammonia. The ammonia is present always in this case gaseous state, right? Then here, preparation of ammonia by Haber process. It is very, very important one. The most of the question papers is containing this question. That's why how to more concentrate about the Haber process. By using Haber process, you have to prepare the ammonia. How to prepare the ammonia? Let's we discuss about this one. Right here, the Haber process combines nitrogen from the air with hydrogen derived mainly from the natural gas, that is methane, into ammonia. In this case, by using Haber process, always we have to use some ingredients like here. In this case, we have to prepare the ammonia by using Haber process. Haber process is based on, it is work based on Le Chatelier principle, which is discussed in first year chemistry. Okay, here second point. On large scale, ammonia is manufactured by the direct union of nitrogen and hydrogen in 1:3 ratio. That means what? Here always we have to use the 1:3 ratio. Okay, in this case, in this Haber process, dinitrogen is reacted with dihydrogen to form ammonia. Already this equation is here balanced. But here the enthalpy is minus 92.3 kilojoule. That means what here? Negative charge, negative sign. Negative sign is indicating as always exothermic reaction. What is this? Exothermic reactions. Okay, the reaction is reversible. The forward reaction is exothermic and it leads to decrease in the volume. That's why it is a exothermic, right? Then here, according to Le Chatelier principle, low temperature and high pressure are required to get the high yield of the ammonia. According to Le Chatelier principle, we have to use the low temperature as well as high pressure. In these conditions, we have to get the more yield of the ammonia. But one thing, using low temperature, the reaction is taking a very more time. That means that it will take the time consuming process. That's why here we have to use some here the temperature is you have to use 725 to 775 Kelvin. Here another optimum condition for pressure is 200 to 300 atmospheric pressure. Okay, this is about the optimum conditions to run the Haber process. Right, then sixth point, iron oxide mixed with a small amount of K2O as O3. That means what? In this step we have to use the iron is acting as a catalyst. Okay, so here using the optimum conditions, by using catalyst we have to prepare the ammonia, right? Here process the pure and dry N2 and H2 mixture is compressed to 300 atmospheric pressure. Then the mixture is heated to 725 to 775 Kelvin and passed over the catalyst. That means what? Here in this case, here we have to insert the hydrogen to this tube. Here also nitrogen also insert this tube, where the hydrogen as well as nitrogen are coming towards here, that is compressor is available. Through this compressor, here those gases are come towards at the chamber of the catalyst. In this chamber, there is available ferrous. After reaction of the dinitrogen react with hydrogen in presence of the catalyst, there is to form ammonia. There is to form here, already cleared mentioned here. In this case here, the in presence of the catalyst chamber, the nitrogen react with the dihydrogen and to form the ammonia like this way. Here this is a liquid ammonia. The chamber is indicating as the liquid ammonia. Here, if any gases are available like nitrogen as well as dihydrogen, those gases are again excess gases are again transferred into pump again and again. Then it is also come towards here in presence of the catalyst chamber. Again, it will take the reaction again to form the ammonia, which is also transferred into here liquid ammonia chamber. Thus, we have to prepare the ammonia by using dihydrogen and nitrogen to yield the more ammonia by conditions under the Le Chatelier principles. But some more reactions are available here. Here when zinc sulfate is reacted with ammonium hydroxide, then you have to get the zinc hydroxide plus ammonium sulfate. What happen here? Here always ammonium hydroxide is reacted with the zinc sulfate to form the zinc hydroxide as well as ammonium sulfate. That means what? Here this OH,
Yes, sir,
the rest of the ammonia